So here we go, back to the videos. 6.4, factoring and solving polynomial equations. Day 3. Last day we're going to be working on factoring when it comes to these polynomial equations. So we want to do the California, or what's been also called the box method. Factoring polynomials in quadratic form, ax squared plus bx plus c. Can I make my equation match in some way, shape, or form ax squared plus bx plus c? Or can I make it look like a difference of two squares, which means I might have an x to the fourth or an x to the sixth somewhere in there. Let's see how this works. First of all, review. Remember, these notes are on PDF, so you can print them out and you can follow along if you like. Factoring quadratic polynomials in quadratic form. Example A, factoring 3x squared minus 17x plus 10. I come over here and I say, what is, I want to use California method, so what multiplies to be 30 and adds to be negative 17. My factors for 30 are 1 and 30, 2 and 15, 3 and 10. Then 4 doesn't work, so it's 5 and 6. The one that multiplies to 30 and adds to be negative 17 is negative 2 and negative 15. I now need to do my fractions. So it's 3x over negative 2, 3x over negative 15. The 3x over negative 2 is 3x minus 2. 3x over negative 15 reduces to x over negative 5. So this is x minus 5. And in green is my final answer. If I FOIL that out, I get 3x squared minus 17x plus 10. Let's try another one. Again, 2 more just to remember how to factor using California method. A times C goes in the first box. 10 times 6 is 60. What multiplies to be 60 and adds to be negative 19? I have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7, 8, 9 doesn't work, so I get 10. My winner is negative 4 and negative 5. So I use my fractions, 10x over negative 4, 10x over negative 15. 10x over negative 4 reduces to 5x over negative 2. So I get the factor 5x minus 2. 10x over negative 15 reduces to 2x over negative 3. So I get the factor 2x minus 3. If I FOIL that out, I get 10x squared minus 15x minus 4x, which is minus 19x plus 6. The last review that we're doing, there's no greatest common factor. Each of these I have been checking for a greatest common factor. I haven't found one. 20 times 8 is 160. What multiplies to be 160 and adds to be 37? So that's 1 and 160, 2 and 80. 3 doesn't work. That's 4 and 40. That's 5 and... Yeah, I'm going to cheat. Excuse me, I'll be right back. So that's 5 times 32, and I can keep on going, but 5 plus 32 is going to give me 37, so I can go and do my factors now, my fractions now. That's 20x over 5 and 20x over 32 this reduces to 4x over 1. This reduces to x over 16. So 4x over 1 becomes 4x plus 1. X over 16 becomes x plus 16. If I pause for station identification. Step back. You should be screaming at me, Mr. Alonzo, you made a mistake. So let's take a step back and let's fix that mistake. 5 and 32 is correct. 20 over 5 is correct. This isn't 2x over 5 over 32. This is 20x over 32. Again, when I reduce this, this is 4x over 1, which was 4x plus 1. When I reduce this, I take out a 4, I get 5x over 8. So that becomes 5x plus 8. When I FOIL that out, I get 20x squared plus 32 plus 5, so plus 37x plus 8. That is my answer. And that's been California method. We've been doing this. We've been doing this for a while. So how does this work? Let's see how this stuff works. Well, here's our first problem. 81x to the fourth minus 16. What? Well, wait. Just like what we were doing 2 days ago, where we asked, is this a perfect cube? I want to ask the same question, but I want to ask, is this 81, oh, that's not what I want to do, is 81x to the fourth a perfect square? The answer is yes. What? 9x squared. 9x squared times 9x squared is 81x squared. That's a perfect square. Okay. How about 16? Is 16 a perfect square? Yes. What? Hold on. Lots and lots of interruptions today. So 16. Is 16 a perfect square? Yes. What? 4. Okay, well then this is a difference of two squares. 9x squared minus 4, 9x squared plus 4. If I were to FOIL this out, and I'm going to do this to show it, 9x squared times 9x squared is 81x to the fourth. 9x squared times 4 is plus 36x cubed. Negative 4x times 9, excuse me, negative 4 times 9x squared is, sorry, that's not x cubed, that's an x squared. Negative 4 times 9x squared is negative 36x squared. Negative 4 times 4 is negative 16. Like always with a difference of two squares, my middle terms cancel, leaving 81x to the fourth minus 16. But wait, there's more. If I move what I just did, this little extra work, this check off to the side, I need to recognize something. Get my little red dots out of the way as well. What do I need to recognize? Well, I recognize that 81x to the fourth minus 16 was a difference of two squares. Excellent. I got 9x squared minus 4, 9x squared plus 4. But this here is also a difference of two squares. That's 3x and 2. So I get 3x minus 2, 3x plus 2 times 9x squared plus 4. Now, if I was doing imaginary numbers, this one here on the right could also be factored. But I'm just doing real numbers right now, so I'm not going to worry about factoring anymore, and I'm going to say that's fully factored. Wow. One more time. I want to look to see if I can read this as a difference of two squares. For letter B, this is a perfect, one more time. This is a perfect square. This is a perfect square. 25x to the fourth. What squared is 5x squared. 36, what squared is 6 squared. Since it's a difference of two squares, this is minus 6, this is plus 6. I cannot factor this anymore, so that's my factors. I'm done. That's a quadratic form of factoring. I've done a few examples. Let's continue. Letter C, 256x to the fifth minus 81. Ugh. 256 is a perfect square. 81 is a perfect square. What's the problem? Well, the problem is x to the fifth and x to the third are not perfect squares. So I need to ask, what's my greatest common factor? X to the third times 256x squared minus 81. Oh, okay, now that's a difference of two squares. So x to the third times the square root of 256 is 16. The square root of x squared is x. The square root of 81 is 9. And so this is still 16x minus 9. Excuse me, plus 9. Now, before you go off any further, you need to ask, is this right here a perfect square? You're going to say 16 is a perfect square, 9 is a perfect square. You're right in both cases. It's a subtraction in the middle. But wait, it's an x, not an x squared. So I cannot reduce that anymore. This is my final answer. Let's continue. Letter D. Let's factor this one. Is there a greatest common factor? Yes. What? 4x squared. When I pull that out, I have x to the fourth minus 5x squared plus 6. That's taking out my greatest common factor. Do you see how this resembles a quadratic? What if I had written this as x squared minus 5x plus 6? Do you see how both of these, I can use the same factoring techniques? I can use basic factoring just like I can on the blue one, I can on the black one. It's going to work the same way. So I'm going to factor this out in basic factoring, the way I normally would factor out if it was what I just had in blue. So in basic factoring, I asked the question, what multiplies to be 6 and adds to be 5? Since it's a negative 5, well, I'm going to do negative 2 and negative 3 will multiply to be 6 and add to be negative 5. So I have 4x squared is my greatest common factor. Instead of x, since this is x to the fourth, I need an x squared minus 2 times x squared minus 3. If I FOIL that out, I get x to the fourth minus 5x squared plus 6. It's just as if it was x squared minus 5x plus 6, but instead of it being just x's here, these are now squares to the second powers. And I'm able to do that same type of problem. In the same format, the only difference is instead of it being an x, it's now an x squared. Let's continue. Same type of problems. Can I factor these? Is there a greatest common factor? I can pull out a 3x. I'm left with x to the fourth plus 2x squared minus 15. Again, this very much resembles x squared plus 2x minus 15. The powers go down by halves. Half of 4 is 2, half of, well, then from 2 I go down to 0. Half of 2 is 1. From there I go down to 0. It's the same format. It's the same format. So I can factor it the same way with basic factoring. I have negative 15 and 2. What multiplies to be negative 15 adds to be 2. Well, that's negative 5. Excuse me, positive 5 and negative 3. So my factors are 3x, my greatest common factor, x plus 5, excuse me, x squared plus 5, x squared minus 3. If I FOIL that out, I get x to the fourth plus 2x squared minus 15. There is my greatest, my factored form. Last example, again, I have 4, 2, and then no x. It's the same thing as if I had said x squared plus 4x minus 21. I'm going to use basic factoring. What multiplies to be negative 21 and adds to be positive 4? I'm getting 7 and negative 3. So I can say this is x squared plus 7. X squared minus 3. If I fill that out, I get x to the 4th plus 4x squared minus 21. Those are all of what I can do, my special factoring types with x to the 4th. So here's a synopsis of what I've been doing over the last 3 days. The first thing I want to do is factor out the greatest common factor. Then I can see if it's a sum of cubes, if I can factor by grouping. By the way, this should factor by grouping down here. This should be ax cubed plus bx squared plus cx plus d. This should be an x cubed, not an x to the 4th. The only x to the 4th that I should see is the quadratic format over here. So those are what I've been doing over the last 3 days. I hope these notes make sense. We'll do some work over this in class. Have a great evening.